Find the acute angle between the vectors 3, 4 and negative 2, 5. Well, let's draw a triangle. So 3, 4, 3 across and 4 up. So let's say roughly there. And let's call that A. Let's call this one O. And then let's go from O to negative 2, 5. So negative 2, 5. Let's say that's about there. So if we know this is the vector 3, 4, the magnitude of the vector 3, 4 we know is the square root of 3 squared plus 4 squared, which is 5. So this length is 5. And the magnitude of negative 2, 5 is going to be the square root of 2 squared plus 5 squared, which is the square root of 29. So this one is root 29. Let's get the third side of the triangle. So let's do that as AB, which is AO plus OB. So AO is negative 3, negative 4, and OB is negative 2, 5. So that one is negative 5 and 1. So the magnitude of negative 5, 1 is the square root of 5 squared plus 1 squared. So that's root 26. Now we want to find this angle, and we can use the cosine rule. So for finding an angle, cos A is going to be b squared plus c squared minus a squared all over 2bc. So in this case, remember in this formula we'd be thinking that this is the angle A. So this is the side A, and this can be B and C in any order. So that's going to be, let's call this angle theta. So cos theta is going to be 29, which is root 29 squared, plus 25, which is 5 squared. Take away 26, which is the root 26 squared, all over 2 times root 29 times 5. So cos theta equals, let's get the calculator, and we've got 29, add 25, take away 26, over 2 times the square root of 29 times 5. So that's 0.5199, and so on. And so for theta, we're just going to do the inverse cosine of the last answer, and that's 58.7 degrees. That was an acute angle. If it had been obtuse, then what we'd have done is just extended down here and found that angle, because we know the angles on the straight line is 180. So if this one had been obtuse, this one would be acute.